My name is Kristoffer, and I'm going to talk about clustering today. Because I feel that clustering is kind of underrepresented, and all the glory goes to classification and reinforcement learning. They know how to spot cars in images or videos. They know how to calculate the next best move in chess. But clustering really doesn't know anything. It doesn't understand anything. And it doesn't get the hype of machine learning lately. But what clustering do know what to do is to group things. And to group similar things into clusters. And we use clustering every day. Netflix uses clustering, and until last year, it grouped all its subscribers on their location, where you live determined what group you were put into, and they used these groups to give recommendations. So people who liked movies or watched movies or series in the group would kind of give recommendations until to other people in this group. But this year they changed the grouping to be based on actually what you watched and how you watched the content instead of where you lived. And they created somewhere between 1,300 and 2,000 global, what they call taste clusters or taste communities, and put people into one or several of them and used these clusters, which are global, to give recommendations. And it works so much better. And the recommendation resulted in much more views and longer views. So, and also they found lots of interesting connections that were not obvious from before, such that, for example, that people who liked Jessica Jones also really liked Kimmy Schmidt, which kind of shows what clustering is about. It's about discovering connections and grouping together things we not initially thought about or knew that would be similar or get in the same cluster. Also, with Stranger Things, they found connection between people who watched different kind of movies and what would make them watch Stranger Things. So they customized the homepage and put different banners on the page dependent on if you liked documentaries or action movies to make you watch the series. Other things you can do with clustering is you can use it on cancer research, and I did a little bit of this in my master, where you try to group together similar cancer cells or patients with similar cancers, and in general discover hidden patterns. Or you can do more not so serious things as to create groups for seminars or other recommendation, and it's perfect for online dating sites where you actually want to group together people that are similar. But this talk is also about bringing some love to clustering, and when you love something you want to know more about it and know how it works. So we will talk a little bit about the details about clustering. There are basically two kinds of clustering algorithms, where the first is k-means clustering, or its variants based on k-means clustering. It works kind of simple. It spreads out all the elements, all the objects you want to cluster into some kind of space, and it randomly, or not so randomly, put down some clusters, which you have you have to define how many clusters you want from the start, and this algorithm puts them randomly around the space. Then it says that everything close to me, if I'm a cluster center, belongs to me, and all the other cluster centers does this, and then it tries to move into the center of mass of the cluster it belongs to, and then again tries to find the closest elements to itself and define it as belonging to this cluster. And then it continues this process until it doesn't move anymore. It is stable. The other kind of clustering algorithm which I really like is hierarchical clustering, and this is the bottom-up variant, where you define every object as its own cluster, and then you try to find the two clusters which are closest together, and you group them into a new cluster or a group, and then you calculate the distance from this newly formed group into every other cluster. And then you just continue this process again and again until you end up with one cluster. And of course it's not useful to have one cluster, it doesn't say anything. So what algorithms usually do is to store all the information about what was clustered at what point, and the distance between everything, and you end up with a tree something like this, where all the vertical lines are clusters and horizontal lines are clustering to the grouping of clusters. And a nice thing about this method is that you can, after the fact, you can decide how many clusters you want in the final result by cutting the tree horizontally somewhere, and you just look at the tree under where you cut. For these algorithms to work, or any other really algorithm in machine learning to work that works on objects, you need to have some properties of the objects to distinguish them or to find similarities and things. And these are has to be numeric properties. And in clustering, it's arranged in vectors, or normally it's arranged in vectors, and they're scaled to be easier to compare. And they're not just put in vectors for fun. It's also because it's useful to be able to place them in some multidimensional space, where each object is represented as a point in this space, and each property of the object is a dimension. So if you have objects with 1,000 properties or features, you will put them in 1,000-dimensional space, which is fun to imagine. But it also has another benefit than just visualization. When you put something in space, you also can use distance measure to calculate the distance between them. It doesn't matter how many dimensions, and normally you do this with Euclidean distance or Manhattan distance. And before clustering can start, in hierarchical clustering, you calculate the pairwise distance between every object. This is, of course, very computational heavy, and there are versions of hierarchical clustering that kind of does some tricks and avoids calculating everything. An interesting part with hierarchical clustering is how you calculate the new distance from a newly formed cluster until to everything else. This is called linkage, and it really changes the behavior of the algorithm. The most common, or the one I like the most, is complete linkage, where when you compare two clusters, the distance between them, the distance is from the two objects that are the furthest away in the two clusters. It's kind of like if you want to join the gang, you need to know everybody. And this tries to maximize the within cluster similarity. If you use this method, you will end up with a tree something like this, which is nice and balanced. Balanced meaning that if you cut the tree anywhere, you will have clusters with similar size or similar number of objects within them, which is often what you want. The other type of linkage is single linkage, which defines the distance between clusters as the two objects that are the closest together in the two clusters. And this is more like if you want to join the gang, you need to know someone. If you use this method, you will end up with a tree more like this. It's a kind of a chain where you have at any cut, you will have a large cluster and many small other clusters, which can be useful in some circumstances, but I'm not a big fan. Something to notice, if you do want to use clustering or try it out for yourself, SciPy's hierarchical clustering is a very good start. It's open and free, and it's easy to modify if you want. But by default, it uses single linkage, so it's worth noticing, and you will get something like this if you do it this way. Okay, is everything good? Is it just love in clustering? Yes and no. There are some difficulties, as in any relationship. At least with k-means clustering and the algorithms based on k-means clustering, you have to define the number of clusters before, which can be kind of problematic because you don't really know how many clusters often that fits the data the best, and you often have to try several times to find something that fits the data. There are some heuristics that helps you with choosing number of clusters and cluster centers and things like this, but it's a difficult problem. It's also it can be very difficult to test the performance of the model you created with your clustering. So with normal or with classification, you have labeled objects. This you do not have in clustering. So with classification, you can say how well you did because you know what objects should have been. In clustering, you don't know before you start which clusters the object should belong to, so you can't really calculate things that you normally would do with classification, such as accuracy or recall or a combination of performance measures. You could or you can calculate the within cluster similarity or the between cluster distance. But in general, it's kind of difficult. Yes. This was a fairly short talk. If you have any questions, I would be happy to answer them. Yes.
You demonstrated a couple of attribute clusterings or attribute cluster algorithms. Did you use any network clustering algorithms in your master thesis, or?
The question is if I used any networking clustering algorithms in my master thesis. In my master thesis, I mainly focused on hierarchical clustering because it's very easy to modify into what you need, and I need to redefine the space you're placing in by creating lots of spaces at parallel. So no, I used mainly a hierarchical clustering, a version of that. Okay, thank you.